Hello dears, today's topic for SD-WAN is direct internet access, DIA. Please leave feedback in the comments. Let's get started for today's lecture. The business need. In traditional wide area designs, internet traffic from remote sites is sent first to a centralized data center or hub site. Then the traffic is pushed through the company's security stack and only then it is routed out to the internet. The returning traffic also traverses the security stack before it is sent back to the remote site. This is typically done because the cost of installing and operating a security stack in every remote location is very high. The image illustrates a high-level overview of a software-defined wide area network, SD-WAN, architecture. Here's a breakdown of the components and connections. SD-WAN overlay. The central curved lines represent the SD-WAN overlay network, which provides a virtualized network layer that abstracts the underlying transport networks, like MPLS, broadband, LTE, etc. This overlay allows for more flexible and efficient routing and management of traffic between locations. V-edges. The small router-like icons represent V-edge devices, which are SD-WAN edge routers deployed at different sites. These devices are responsible for connecting to the SD-WAN overlay, ensuring secure and optimized traffic flow between locations. V-edges can be deployed in branch offices, data centers, or cloud environments, providing consistent and secure connectivity. Connections. The red lines signify the data paths within the SD-WAN overlay, indicating the flow of traffic between different sites. The image shows how different sites, depicted as buildings with data centers, are connected through the SD-WAN overlay using the V-edge routers. Cloud services. The icons at the top, Microsoft Teams, Salesforce, represent cloud-based applications and services that the network might connect to through the SD-WAN. These services are critical for business operations, and SD-WAN ensures optimized, secure, and reliable access to them. Security and management. The icons on the right-hand side, firewall, analytics, etc., indicate the security and management services integrated into the SD-WAN solution. These could include firewall, providing security and threat protection. Monitoring/analytics, for performance tracking and troubleshooting. Optimization tools, ensuring optimal performance and efficient use of network resources. Users and branch sites. The bottom left icons represent users at branch sites or remote offices. The SD-WAN ensures that these users have seamless access to cloud services, other branch sites, and the data center with improved performance, security, and reliability. However, the fast adoption of internet-based applications and teleworking created the following issues with this WAN design. Scale. With the ever-increasing internet demands at each remote branch and the use of SaaS apps such as Office 365 and Salesforce, backhauling the internet traffic from every branch to the data center creates a bottleneck at the DC's internet circuits. In addition, the centralized security stack and the network devices at the DC must scale vertically with the number of branches. Apps performance. By rerouting traffic from the branch to DC to the internet and back, applications incur increased latency. Depending on the underlying geography, this can result in significant performance degradation for some business-critical apps. Cost. Having said the above, it is obvious that the centralized hub site must scale vertically when the number of remote sites increases. This implies higher hardware and WAN costs at the data center location. Cisco SD-WAN allows for a better, more scalable approach to internet usage at remote sites. The feature is called direct internet access, and as the name implies, it allows particular users and applications to access SaaS/IaaS services directly through the local internet circuits. Cisco SD-WAN Direct Internet Access, DIA. Cisco SD-WAN Direct Internet Access is a solution that improves the user experience for SaaS applications at remote sites by eliminating the performance degradations related to backhauling internet traffic to central data centers. DIA allows control of internet access on a per VPN basis. The image shows an SD-WAN, software-defined wide area network, architecture with a focus on direct internet access, DIA, for secure and optimized cloud connectivity. It illustrates how different sites, such as data centers and branch offices, connect through SD-WAN overlay networks using V-edge routers. Key features include SD-WAN overlay, provides secure, efficient routing over multiple transport types, MPLS, broadband, LTE. Direct Internet Access, DIA allows branches to directly access the internet for cloud services, example Microsoft Teams, Salesforce, without backhauling traffic to a central data center. Integrated security services, the architecture incorporates firewall, monitoring, and analytics for enhanced security and visibility. Centralized management, SD-WAN ensures that all locations are centrally managed, optimizing application performance and user experience. This setup provides a modern, flexible, and secure network solution that enhances access to cloud services and optimizes network traffic. Security. Cisco SD-WAN allows pushing the security stack directly on the WAN edge devices on site. This reduces the need for security appliances at every branch, by providing inbuilt security features which include DNS security, application-aware firewall, URL filtering, IPS/IDS, and advanced malware protection, AMP. In addition, instead of enabling the security stack at the WAN edge routers, the DIA feature allows for routing the traffic through a cloud security provider. In this case, the traffic from a particular remote site is routed to the cloud security provider through point-to-point IPsec tunnels. The cloud security provider then pushes the traffic through the predefined security policies and route it out to the internet. Guest access. Cisco SD-WAN provides an easy and secure way to create an isolated guest segment that is isolated from the enterprise network and has its own security policies. Typical DIA traffic policies include restricting bandwidth usage of guests' users, restricting access to certain internet resources, restricting access to internal enterprise resources, protecting the network from malicious content.